Hey guys, Vladimir here. So today I'm gonna talk about creating a new web application on AWS. I'm gonna present this talk using a mind map, uh, which is on a side note a really cool tool to map out some of the moving parts and some of the components. So let's start. Well, first and foremost, you have to think about what language you're going to use for your application, right? So, most likely, and I'm going to just assume the obvious, most likely you're going to have a front end and you're going to have a back end. So, my go-to languages and frameworks for the front end are ReactJS and the Amplify SDK whenever I work with AWS. For the backend, the language that I use mostly is Kotlin or Java. Yeah, I sometimes use Python as well, sometimes use Node.js, but for the most part, I'm comfortable writing my code in Kotlin and uh, I'm actually in love with that language. So now that this is kind of chosen, let's talk about some of the components here. Well, let's start with the front-end hosting. Where are you going to host let's assume we chose React. Where are you going to host it? Well, I would host it on S3 and I would front it on CloudFront, by CloudFront. CloudFront is our CDN. S3 is an object storage service. A lot of people don't know actually, but you can host your web applications on S3 as long as they're single page applications, SPAs. There's also a good service, it's called AWS Amplify. It does the hosting for you and it actually pulls the code from a Git repo for you and just deploys it every single time you commit. That component I will touch upon in the code repo CI/CD section later on, but AWS Amplify does it for you. Next up is the backend compute, right? So let's assume I'm using Java. Where would I host my Java code? Well, there's multiple options here. As you can see, there's uh, two main ones, which is the serverless approach and the containers approach. So going with the serverless approach, you can obviously have your Lambda functions. And Lambda is great for your code. It's actually excellent. I mean, you just write the code, you commit it into a Git repo, and if you set up your CI/CD pipelines, everything is deployed for you in an automated way. So one thing to consider is if you're using Java for your backend, make sure that you're fine with the cold start that Java usually experiences. The cold start is usually in seconds. So if let's say nobody's using a website and the first time somebody is calling some kind of a function on your website and you're hosting your code in a Lambda function, then the user is gonna experience a cold start. This also is going to be true for bursts, spikes in usage, because those Lambda functions need to be cold started, and again, the user is going to experience cold starts. Uh, now, I, for the most part, when I use Java to develop my apps, I use containers. And for the most part, I use Fargate. Fargate is a fully managed container service. You can have Fargate for the EKS service, which is the Kubernetes service, or ECS, which is the AWS homegrown service, container service. That's how I approach most of my development. I love Fargate. I mean, I don't have to worry about managing these containers. I don't have to worry about resiliency, durability, because everything is taken care for me. If you don't want to go the Fargate route and you want to tweak all of the parameters yourself, then go the EKS or ECS route, as you can see in the mind map. So the EKS or ECS route is great for more complex and all-encompassing applications. So I'm actually a huge fan of EKS. I use ECS as well. It's great. It's easy to start with. But for some reason, I'm leaning towards Kubernetes just because, it's uh, I find it interesting. So again, if you have a huge ecosystem that you want to build out, consider one of those services, EKS or ECS. Now, when you're talking about your code, you need to front it somehow. You need your web application to be able to talk to it. How would you do that? Well, you can use three main ways of doing that, right? So you can use the API gateway, you can use an application load balancer, or you can use Route 53. API gateway is a natural fit with Lambdas. It's also a really good fit with your container services, but you have to have another layer in front of your container service or behind your API gateway, something like an NLB, network load balancer. So I almost always use API gateway when I have Lambda functions. I almost always use the application load balancer when I have container services, when I use, let's say, Fargate or EKS or ACS. Almost always. That's how I basically break it down. The difference between the two are quite significant, so I'm not going to really go into it here. By the way, one thing that I didn't include here is the HTTP API. It's part of API Gateway, but it's more simplified gateway, and therefore it's cheaper. It's significantly cheaper than API Gateway. It doesn't give you the flexibility that API Gateway provides to you. Like it doesn't have a lot of transformations and things like that. But uh, it's also definitely I'm starting to use it for my Lambda functions as well. The third option, which I don't recommend, but you still might want to consider it, is to front your, let's say, EC2 instances with, I'm sorry, not EC2 instances, your containers with Route 53. Route 53 is our DNS service, and you can um, you set it up in such a way where you can use Route 53 as that ingress service. So basically, you'll be able to route directly to your containers from Route 53, bypassing an ALB even. It's much more complicated. It has its own restrictions, and I just wouldn't use it. I would go the ALB route if I'm using my containers. And there's really no clean way of kicking off your Lambda functions from Route 53, so I'm not even going to discuss that. So I mentioned that you have these gateways, but you most likely would want to secure them. And you want to make sure that if your application is multi-tenant, which let's say my application is, then you want to make sure that the user is able to log in and is able to securely access his information. Um, how do we do that? Well, you can use one of the services that we provide, which is Cognito. So I included Stormpath and Auth0 as well here. They're great services. Cognito is the service provided by AWS. I've used all three of them. I like Cognito the most because it has more intrinsic integrations with AWS. So as an example, with a click of a couple of buttons or just one configuration, I can link API gateway with Cognito and set up the auth and part of it with Cognito, and also Auth0 as well using scopes. So I usually default to Cognito, and Cognito has a really generous free tier, 50,000 monthly users for free. So it almost always is my go-to user directory service. So what happens is um, when a user authenticates using Cognito, Cognito provides you three tokens, an access token, ID token, and a refresh token, and you would supply the access or the ID token to API Gateway in order for API Gateway, let's say, to authenticate the user or check the authentication status of the user. Now, You can also do the check within your code as well. So you don't have to do it at the API gateways level. And HTTP API does that as well for you. You can HTTP API would check the validity of the JWT tokens as well. But you can always do that check yourself within code. I have a couple of web applications where I showcase how to do that. I might share the web application afterwards. So that's basically the gist of it. A user authenticates using Cognito as an example, and what I want to do afterwards is, and I'll mention it a little bit later in the presentation, is propagate some of that data, that user data, to other data stores for further processing and for further, I would say, relationship mapping. All right, so I've discussed the back end and the front end code, but I really am a fan of CI/CD when it comes to my code. So what are some of the options here? Well, we have the whole cold star stack, and you can set up your CI/CD pipelines using code pipeline. You can set up the build process using code build. You can have a Git repo, which is code commit, and you can have a code deploy your actual code. So you can do a lot with that. I use CodeStar quite often. My um, most popular or most loved external service is GitLab, actually. GitLab is an excellent service that I love using on a daily basis. It provides the Git repos and or the Git repositories, and it also provides the CI/CD pipelines, which are really easy to set up and use. GitHub is also a service that I use for mostly my open source projects. But it also provides you a way to, I think they're called GitHub events, to set up your CI/CD pipelines. Next is, let's switch to logs here. Well, you want to make sure that whenever you deploy your logs, let's say, or your application, your backend application, you want to make sure that you understand what's going on with it, right? So if something fails, you want to make sure that you understand how to analyze it. You want to make sure that you aggregate some of those logs. CloudWatch Logs is our service that allows you to, it actually is used as the default log aggregator for, let's say, your Lambda functions. And it can also be used for your containers, especially when we're talking about Fargate containers. So it basically gathers all of those logs, and you can do a lot with them. You can export those logs into S3, which is again the object service. You can pipe those logs into an external log service, such as Logly, as an example, or Splunk. There's an easy way to integrate a Lambda function that will just pipe the newly created logs to an external service or any other service, even an internal service. There's also an easy way of piping those logs into an Elasticsearch cluster. So we have an Elasticsearch service that manages the whole Elasticsearch cluster for you. So you can actually set up um, your propagation of this log data again with the click of a button to your Elasticsearch cluster. X-Ray allows you to do a deep dive into your application and debug your application. So it gives you an ability to understand where things are failing and where things are taking too slow to execute, and um, gives you a bit more information in that regard. It's a great service to know. Next up is, well, let's switch to data storage. So data storage, we have a lot of options for data storage. Whenever I need freeform text searching, I use Elasticsearch. I don't know if you call it a database. It's not really a database because I would still have the source of truth somewhere in, let's say, a DynamoDB table or tables. But Elasticsearch is a great way to allow your end users to search text data. I use DynamoDB for most of my applications, at least in some capacity, because it's just my go-to service. It has really also a generous free tier, I think uh, 25 read capacities units and write capacity units for free. RDS is the relational database service. So RDS includes a whole bunch of databases underneath. Really cool service to explore if you're a fan of relational databases. And in some cases you have to use a relational database. Aurora is our fully managed relational database service. It includes MySQL and Postgres. I actually use Aurora MySQL quite often, especially when I have a lot of data where I need to run joins on. Um, Neptune is the I would say the GraphQL database or the graph database, not GraphQL, graph database. DocumentDB is the MongoDB database. Keyspaces is the Cassandra database. And again, all of these are fully managed for you. So all you have to do is just click a button and it works. And Elasticache, again, it's not really, I mean, yeah, you can think of it as a data storage service, but it's a caching service. So it provides Redis and Memcache as a service. All right, so the next step is static assets. Where would I store all of my images, videos, documents, PDFs, and things like that? Well, I would store them in S3, and I would definitely front S3 with CloudFront, because at the end of the day, it's going to be much cheaper for you if you have any significant traffic. Now, async processing. Let's talk a little bit about that. Um, you have let's say a lot of images, right? And you allow the users to store those images in S3. And you also want the user to be able to search your images based on some kind of a parameter, let's say labels. Well, when you store something in S3, you have the ability to set up S3 events, which would kick off an event and it would trigger even either an SQS queue, or basically it would add an event message to an SQS queue, or it can trigger SNS, or it can trigger a Lambda function. And what that does for you is it decouples that secondary processing of this data, right? So you can create a message bus, which allows your application to process this data in a meaningful manner um, at your convenience without overloading your downstream services. So you would use something like SQS for that. You would use ActiveMQ for that. You can use DynamoDB streams for every single time you um, update or add or delete a DynamoDB element of value. It can create a event for you. Well, basically would create some kind of a message in a DynamoDB stream, and you can read from the DynamoDB stream using a Lambda function or a container, and you can act on the actual change. So again, these services, whenever you're creating a web application, think about the async processing as well as synchronous processing. Async processing is becoming more and more important uh, due to the sheer volume of usage on some of these websites. So as an example, let's say I weren't using async processing and I let my users upload images, and I want my users to be able to search those images by some metadata hidden in the image itself. If I weren't using async processing, then what I would have to do is I would allow the user to upload an image, and then I would, within the same request, basically, I would do image analysis and take this metadata and store it somewhere. And basically, I would block the user on this upload. So the user won't be able to use the website. And this is a very trivial example, but it's an example that I've seen all over the industry. So it's quite important to understand why async processing is a necessary step whenever you're thinking about a web application. The other part that I want to discuss is user notification. How do you reach out to your users? How do you target your users? Well, you can use SNS or Pinpoint. So Pinpoint allows you to target users. First of all, it allows you to collect user data, user activity. So as an example, you can create custom events and or custom data collection events, basically, throughout your website, and then you can figure out who's using your website and how. And then you can also target those users using Pinpoint, using special campaigns or custom campaigns. SNS provides the ability for you to send text messages, send push notifications, and emails. So it's a bare bones service that does this out of the box as well. You can't really do campaigns with SNS, meaning it doesn't provide you the functionality to kind of segregate your users and do campaigns. Pinpoint is a much more robust service for that. But SNS is a bare bones service that lets you do the actual reach out. And the last but not least, the dev stack. So I love using Amplify, the Amplify SDK, to interact with my AWS resources because the Amplify SDK makes it just so much easier to interact with those resources. It signs the requests, and it actually has a lot of higher level objects that it facilitate the interaction with those services. So as an example, if I'm using AppSync, which is a GraphQL service, then I would definitely go with Amplify because it just makes it way too easy to use. If I'm uploading images to S3, I would use Amplify. If I'm, calling AWS services and I need to sign those requests, and most of the endpoints need to be signed with a SIG4 signature, then I would definitely use Amplify because again, it just the Amplify SDK because it simplifies this process for me. Well, guys, I hope you found this useful. Let me know what else you'd like me to talk about, and please subscribe and leave comments.